All right, welcome back. So in the first video, we talked about uh, what is anti-differentiation by parts. We came up with this formula. And what we're going to talk about right now is we're going to talk about the choices that we made right here. And we'll get into more specifics as we go along as to what's the general rule for making these choices. But what we want is we want for to choose u so that the derivative of u is simpler, and choose dv so that the antiderivative of v is at the very least not more complicated, so that the antiderivative of dv is not more complicated. It doesn't have to be simpler, but it needs to not be more complicated. So what I'd like to do is do the exact same problem. This is example 2. The integral of x cosine of x dx. And I am going to choose u as cosine of x, and I'm going to choose dv as x dx. So let's see what happens. Well, du is equal to negative sine x dx. Notice that it didn't actually get simpler. And v is equal to 1/2 x squared. It got more complicated. This gives us u times v 1/2 x squared cosine of x minus the integral of v du, so that's of negative sign, so we'll make that a plus 1/2 x squared sine of x dx. More complicated, not less. Generally, this is how you know that you've gone astray, because you get more complicated instead of less complicated. All right, so let's do another example where perhaps it doesn't get more complicated. This is officially example 2 because I'm not reading my notes very effectively as we go along. By the way, I apologize for the lag in my pen. I'm not sure what's going on there. After this video, I'll probably restart the laptop. Let's take a look at the integral of x squared e to the x dx. Now, clearly, if I choose dv to be equal to e to the x dx, it will not get more complicated when I take the antiderivative, so that's a good choice. And so therefore, u is x squared. The derivative, of course, will be less complicated, and the antiderivative is no more complicated. And so now what I've got is u times v x squared e to the x minus the integral of v du, which is 2x e to the x dx. Notice I still don't know the integral of that. I don't know the antiderivative of x e to the x, but what I can do is I can just do parts again. So why not? Let's do parts again. So we'll come down here. Let's switch to blue for the second round. And we will set u equal to 2x. We will set dv equal to e to the x dx. Notice that the derivative of u gets simpler, which is what we're looking for every time. And the antiderivative of v gets no more complicated, which is our minimum rule. And we get x squared e to the x minus, now be careful, I know you're all good at math, minus big parentheses, because we're going to have minus a minus in here. And we'll go back to our blue color, uv 2x e to the x minus the integral of v du 2 e to the x dx. And now we can simplify, and we get x squared e to the x minus 2x e to the x plus the integral of 2e to the x dx. And hey, how about that? We know the antiderivative of this, so for all intents and purposes, we are done. We'll take one more quick step and write it all out, and we get that the integral equals x squared e to the x minus 2x e to the x plus 2e to the x plus a constant. And there is the integral of x squared e to the x with respect to x. And you can do this indefinitely, just so long as it gets simpler every time. We had an x squared, then we had a 2x, and then we just had a 2. All right, my students, why don't you go ahead and do exercise 5 out of the book, and we will be back with more examples. Thanks for watching.